syllabus. So whatever the chapters you are having, all the chapters are available. I'll be sharing today to you the Google Drive link wherein we have that textbook, PPTs, and as well as some content related to ML. You can have a look about it. So today we'll have some terms that we have discussed in the previous class also, but in more detail we'll be learning here as per the syllabus. Because in the PPT it was much clear with respect to the topic. So I am now referring once more to the textbook. So what are the elements that are most important, that are most required for the machine learning? Because when we are talking about one second. So when we're talking about machine learning, itself explains like learning of a machine. So the machine understands zeros and ones. At that instance, we need to analyze that mathematical imputation computations are much more useful for this purpose to understand what are the different concepts that are utilized in machine learning. So coming to here, the generic structure of machine learning problem and the data that is employed. So when we are talking about the machine learning, the important concern comes here to learn the data. That is, as we know, there is a lot of data that is labeled or unlabeled data. Maybe it may be time series data, it may be a continuous data, it may be a discrete data. We have different types of data, right? Data instance wherein I may have a continuous data, I may have discrete data, I may have a time series data, I may have a decimal data. So with respect to that data, the data has to be analyzed, so has to be processed, to be viewed, to know that what exactly a data is. That is the first generic structure where the machine learning is learning about a problem here. The next one is it is like properties of machine learning models and their impact on the performance. That is, once the data is analyzed, then we are moving towards the ML models, which are useful for the performance to get a better outputs or better performances. The third one is class balancing. So depending upon data implementation, we analyze or we balance the data with respect to the performance or with respect to the output required. The next one is elements of statistical learning, like we have maximum posteriori and maximum likelihood estimation. These are the type of statistical learning depends upon probability or depends upon the what is the best performance of an analysis of any particular data with respect to the performance. The next one is introduction to information theory with a focus on the most of the data where we have much ML tools. So once we analyze all this concept, we see that what are the different methods or different focus that we use ML tools here. So for this one, we are moving forward. So what are the data formats? So here we can have a look here saying that as we know, the data is classified as both supervised and unsupervised. In supervised and supervised learning problem, there will always be a data set defined as finite set of real vectors with m features are like any value a, which is nothing but a subset of all x1 to xn, where xi is any data item is which is belongs to the relation m. Which what is m? A subset or a complete set of what is it? Sub knowledge of a particular distance process of a m. So considering that our approach is always probabilities, so whenever we see that probabilistic is a nature where we identify the nature of a data which is nearer to the content of main problem. So we need to assume each x has drawn from statistical multivariate distribution, and with respect to that, we see that how data generation process is applied. So, with respect to this, we have here where we see that once we analyze about the data, where we are having the data, which is a probability of data X with respect to a data item, we expect all samples to be independent and identically distributed. So this is the way where we exactly see what is data, what type of data, how much it is accurate to a particular performance of the data. For this, we have formula here, P of x1, x2 till xk, pi of I equals to 1 of k, where it depends upon the performance of that particular data item. So here we see this. This is the main task that are based on the assumption of working with all well-defined distributions of a data with respect to the considering the interaction between an agent and an unknown situation. where we see that there are possible objects where we have a lot of way. Whenever a finite data set is employed, the reader must always consider the possibility of copying with new samples that share the same distribution. That is, whenever the new element comes into existence, the previous values, depending upon this, has to be enhanced so that the better performance of any particular data item of any particular value of the particular data is has to be exaggerated. The corresponding output values can be both numerical, continuous, or categorical. That's, as I said, that depending upon the type of a data, it goes with output also. Like normally, if I say 2 plus 3 equals to 5, and if I say 2 plus 3.5 equals to 5.5, that means that 2 plus 3 is nothing but numerical value or real numbers. If I'm saying that 2 plus 3.5 equal to 5.5, that means that it is a decimal value. So types of input determines the type of output. Similarly, here the type of a data which is being utilized, it also gives a different format where we see that whether the type of output determines the numerical data, continuous data, or categorical data. So first we'll see that it is in the first case the process is called regression. That is, we have seen in the previous topic of supervised learning where we have classification and regression. Classification is a categorical data, where in regression we perform with respect to related to numerical outputs of continuous and numerical data there. So the first process is called regression, while in the second it is called classification. So related to this, we have some terms. Examples of numerical outputs are like suppose we will take data set or one data set which is y, which is of any of the list of the elements of y1 to yn, whatever the list of elements of data sets you're providing. This y1, y2, yn, or x1, x2, xn are nothing but the data set attributes. Like if I'm saying a table, a student table, if I say, what does the student table consist of? Student roll number, hall ticket number, name, father name, mother name, age, subjects, type of a student, grade, section, hobbies, multiple attributes are there. So these are nothing but the y1, y1, y2, yn, or x1, x2, xn are the multiple attributes of that particular data set. With respect to that, where we see that where yi, that is any of the value, should belong to 0. Either it is to that y or it is not to that y, or yi belongs to the r plus. The r plus determines that what exactly, whether it is a discrete value or continuous value. So depending upon this, we analyze that if it, when the label can assume a finite number of values, for example, it's binary or bipolar, the problem is discrete. That each, while it is continuous, called that y of I equals to r. So here we see an example here. If yi belongs to red, black, white, green, or yi